Welcome to the Explainer. So today we're going to tackle Node JS. And look, if you've ever wondered how things like chat apps or those online games you play, or even, collaborative documents, how they handle thousands of people at the exact same time without just falling over, well, a lot of the time, the magic behind that is Node JS. So let's kick things off with a question that, honestly, keeps a lot of developers up at night. I mean, think about it. Our apps are getting bigger, and we all expect everything to be instant, right? So how on earth do you build a system that can juggle thousands or, hey, even tens of thousands of people all connected at once and do it without breaking a sweat? And that right there, that's the core problem that Node.js was born to solve. See, our expectations for software have totally changed. We're way past just simple static web pages. We want those rich, collaborative experiences, multiplayer games, real-time document editing, you name it. But the thing is, a lot of the traditional tools servers used, well, they were built for a much simpler time, a world of just ask and receive. All right, so here's how we're going to break it down. First, we'll get into the why, the big concurrency challenge. Then we'll dive into the how, Node's asynchronous magic and its use of streams. And finally, we'll look at the what, all the cool stuff this architecture lets us build. Okay, first step, the concurrency challenge. To really get Node, you got to start with the problem it was built to fix. So Node's creator, Ryan Dahl, he had this super clear mission. The goal wasn't to be the absolute fastest thing for every single task out there. No, it was about making it way, way easier to build programs that have to juggle a massive number of connections simultaneously. Okay, so just look at the difference here. The old way, well, a lot of traditional servers used what's called a thread per client model. Just think of a thread as a dedicated worker. So for every single person who connects, the server has to hire a brand new worker. You can imagine how that gets crazy expensive super fast. It just eats up memory. But Node's approach? Totally different. It uses one single super efficient worker for everybody. And here's the real killer with that old model. Those workers, they were often I/O bound. That's a fancy way of saying they spent most of their time just waiting. Waiting for a database to answer, waiting for a file to load from a disk. The whole operation just grinds to a halt. It is literally like paying a whole staff of people just to stand around and twiddle their thumbs. So inefficient. All right, so if the big problem is idle workers, how does Node fix it? Well, its answer is, honestly, it's pretty counterintuitive. It takes this whole problem and just flips it on its head. And here is the big radical idea. Instead of having a bunch of workers doing one job at a time, Node has one worker that juggles a ton of jobs at once. It's like a master multitasker. It gets a request, hands off the slow part, like reading a file, to someone else, and then instantly moves on to the next task. It never, ever waits. So how does it manage this whole juggling act? It's all run by something called the event loop. And the best way to think of it is like an air traffic controller, but for computer tasks. It's constantly scanning, looking for new requests coming in, and checking if any of the slow tasks have finished. As soon as one of those I/O things is done, the event loop grabs a result and makes sure it gets back to where it needs to go. Okay, let's just walk through the steps, because this is really cool. First, our JavaScript code kicks off a slow operation, like a database query. But instead of waiting, it immediately delegates that heavy lifting to a library called libuv. Now, the crucial part, our main thread is not blocked. It just keeps on executing other code. Then, when libuv is done, it sends a signal. That signal tells the event loop, hey, I'm finished, and the loop then takes our callback function, the code we wanted to run with the result, and puts it back on the main thread to be executed. The main thread is never, ever just sitting around waiting. All right, so with all this asynchronous data flying around, how does Node not get completely overwhelmed? Well, the answer is its secret weapon, a super powerful concept called streams. The secret here is to treat everything like a flowing river of data. I mean, think about it. Instead of trying to load a gigantic file or a huge chunk of data into memory all at once, which is a great way to crash your app, by the way, Node just processes it in manageable little chunks as it arrives. Exactly like a river, it flows bit by bit, not as one giant tidal wave. So what are streams? Really, they're just interfaces for handling this flowing data. And because they're used everywhere in Node, for files, for networking, they're super consistent. They're also incredibly efficient with memory. But the real magic, the part that's so cool, is that they are composable. That means you can easily pipe the output of one stream directly into the input of another. It lets you build these really powerful data pipelines with almost no effort. Okay, so this brings us to the big payoff. We've talked about the why and the how. Now for the what. What kind of amazing applications does this whole non-blocking, stream-powered architecture actually let us build? This is where it all clicks. And to really appreciate why Node is such a game changer for real-time apps, you have to look at how we used to do it. The old way was AJAX polling. It was basically like having your app constantly ask the server, anything new? Anything new? Anything new? Over and over again. Super inefficient. But Node is perfect for modern stuff like WebSockets. That's a persistent two-way connection for things like chat or gaming, and server-sent events, where the server can just push updates to you when they happen. And the whole point of all this, the goal, is to get those updates to happen in under a second. You know, when you send a chat message, you want it to appear instantly. And that's exactly what Node's non-blocking design is made for. That super low-latency communication, even with thousands of people connected. Okay, so we've established Node is incredibly efficient on one thread. But wait a minute, our computers today have multiple CPU cores, right? So how does Node take advantage of that? How does it handle truly massive scale, what people call the C10K problem, which is basically handling 10,000 connections at once? The answer is something built right into Node called the cluster module. It's brilliant. It lets a single Node app take full advantage of all those CPU cores. Basically, a master process kicks things off, and then it forks or creates copies of multiple worker processes. You usually have one for each CPU core. They all share the same network port, and that master process just acts like a traffic cop, automatically distributing all the incoming connections between the workers to balance the load. It's awesome. And this quote really nails Node's core value proposition. It's not just about raw performance. It's about making this really complex world of high concurrency programming accessible. It gives developers these well-designed, predictable tools to solve problems that honestly used to be a massive headache. So, when you step back and look at it, by fundamentally solving that I/O bottleneck, that whole problem of processes just sitting around waiting, Node really did unlock the door to a whole new generation of software. And that leaves us with one last, really interesting question to think about.